Welcome to the next session. Now in this session, we discuss classroom workbook followed by the concept gamma and beta functions. Now let us start the session with question number 56. Question number 56. The value of the definite integral I equal to integral 0 to 1 sin inverse x whole square divided by square root of 1 minus x square dx is, options are given. Let us see. Integral 0 to 1 sin inverse x whole square divided by square root of 1 minus x square dx. Here the derivative of sin inverse x is 1 by square root of 1 minus x square. So let p equal to sin inverse x. So differentiate this. dp equal to square root of 1 by square root of 1 minus x square dx. Now these are limits of x, but x is converted to p. So let us find the lower and upper limits of p. So upper limit of p equal to sin inverse of, what is upper limit of x? 1. So this is sin inverse 1 is pi by 2. Lower limit of p is nothing but sin inverse of, lower limit of x is 0. Sin inverse 0 is 0. So lower limit is 0, upper limit is pi by 2. Therefore this integral I will be equal to integral 0 to 1. So this is pi by 2. Integral 0 to pi by 2 sin inverse x whole square. Actually sin inverse x is p. So p square. This dx by square root of 1 minus x square is dp. So integral p square is p cube by 3 followed by the limits 0 to pi by 2. Now replace p by upper limit. This is pi by 2 whole cube divided by 3. So this is pi cube divided by 24. So the required integral is pi cube divided by 24. Note this. Now let us discuss few concepts on gamma functions and beta functions. So next we discuss definition of gamma function. Suppose n is a real number. N is a real number. Now the gamma function for this n is denoted by this symbol. This is read as gamma of n, which is defined as the integral 0 to infinity e power minus x into x power n minus 1 dx, provided the integral exists. Provided the integral exists. What do you mean by the integral exists? Integral exists means it's a finite value. So whenever for certain values of n, if this integral gives some finite value, then gamma of n is defined like this. What does it mean is, don't think that gamma function is valid for all real numbers. For certain values of n, it is valid. Suppose when you start with n values in natural numbers, n values are 1, 2, 3, 4, etc. Then gamma function is valid. Suppose if n values are multiples of 1 by 2, 1 by 2, 3 by 2, 5 by 2, etc. Now for certain these values, gamma function is valid. But when you look at, for example, irrational numbers, for example, root 2, gamma of root 2 may not be exist. So therefore, when certain values of n, if this integral is finite value, then we can denote it as gamma of n and divide by this integral. Integral 0 to infinity e power minus x into x power n minus 1 dx, provided the integral exists. Suppose when you replace n by 1, then gamma of 1 is integral 0 to infinity e power minus x. This quantity will be 1. Integral e power minus x is minus e power minus x. Apply the limits from 0 to infinity. So minus e power minus infinity plus e power minus 0. So this is minus 1 by e power infinity plus 1. 1 by e power infinity is infinity. So this is 1. Therefore gamma of 1 is 1. So what we are doing is, we are integrating this function e power minus x into x power n minus 1 on entire positive x-axis. Basic concept of integral is, it gives area. So integrate this function e power minus x into x power n minus 1 on entire positive x-axis. So whenever for certain values of n, this gives a finite value, then gamma of n is denoted by this and defined by this integral 0 to infinity e power minus x into x power n minus 1 dx. This is so powerful function. This function we use frequently in the probability distributions of certain curves. Okay, so this is so powerful in the evaluation of many definite integrals. Write the definition. Let n be a real number. Let n be a real number. Then gamma function for n is denoted and defined as gamma of n equal to integral 0 to infinity e power minus x into x power n minus 1 dx, provided the integral exists. Let n be any real number. Then gamma function for n is denoted and defined as gamma of n equal to this, provided the integral exists. So remember this definition, do this calculation. Now let us discuss some useful points which we use frequently in solving many questions based on gamma functions. Gamma of n plus 1 is nothing but n times gamma of n. In place of n, write n plus 1 and do the integration by parts. It gives n times gamma of n. When you apply recursively, continuously this, then gamma of n plus 1 is nothing but n factorial. Gamma of n plus 1 is n factorial. This is another useful result. So that means if it is n plus 1, I have n. If it is n, then this becomes n minus 1 factorial. Gamma of n is n minus 1 factorial. This is my basic value. Gamma of n plus 1 is n times gamma of n. Gamma of n plus 1 is n factorial, and if it is n plus 1, we have n factorial. To get this result, we need to apply this gamma function many times, because if it is n plus 1, this is n. Now next it becomes n minus 1, next n minus 2, n minus 3, like this. So n into n minus 1 into and so on 1. So finally it will be reduced to n factorial. So if it is n plus 1, we get n factorial. If it is n, it will be n minus 1 factorial. Another useful result is gamma of 1 by 2 equal to square root of pi. This is very useful information for us. Gamma of 1 by 2 equal to square root of pi. Now, based on these values, let us try to find gamma function for certain values. Suppose I want gamma of 3 by 2. This 3 by 2, we can write it as 1 by 2 plus 1. Now this is in the form of gamma of n plus 1. So n value is 1 by 2. Apply this result, we get half into gamma of 1 by 2. So this is 1 by 2 into gamma of 1 by 2 is square root of pi. So therefore the value is square root of pi divided by 2. In the similar way, if you want gamma of 5 by 2, this 5 by 2 we can write it as 3 by 2 plus 1. Now this is again in the form of gamma of n plus 1. Here n value is 3 by 2. So this is 3 by 2 into gamma of 3 by 2. This is 3 by 2 into gamma of 3 by 2 is square root of pi divided by 2. So therefore this is 3 times square root of pi divided by 4. Now similar to this, we can easily manage the value of gamma of minus 1 by 2. So these are positive values 3 by 2 and 5 by 2. Let us handle for negative fractions gamma of minus 1 by 2. We have a result gamma of n plus 1 equal to n times gamma of n. Formula number 1. Now take n value minus 1 by 2. So therefore this becomes gamma of minus 1 by 2 plus 1 equal to minus 1 by 2 times gamma of minus 1 by 2. So but we want gamma of minus 1 by 2. So therefore this gamma of minus 1 by 2 equal to cross multiply this, you get minus 2 times gamma of minus 1 by 2. So this is, when you simplify this, you get 1 by 2. So minus 2 times root pi. So interestingly, gamma for 3 by 2 is a multiple of root pi. This is a multiple of root pi. This is a multiple of root pi. So when you are handling gamma functions for multiples of 1 by 2, answer will be again a multiple of square root of pi. we use this result. Gamma of 1 by 2 is root pi. So write all these points. Hope you understand all these points. These are very, very important points in solving many questions based on gamma functions. Next we discuss beta function. Suppose we have two real numbers m comma n, two parameters. In simple we call them as variables. M comma n are two variables. Then the beta function for m comma n is denoted by this beta of m comma n, which is defined as the definite integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 dx, provided the integral exists. Provided the integral exists. So this is the definition of beta of m comma n. When you compare this beta function with the gamma function, for gamma function single parameter is required. But in case of beta function, two parameters are required, m comma n. Now we are integrating this function from 0 to 1 only. This is a polynomial expression. So x power m minus 1 into 1 minus x whole power n minus 1. Of course, if you treat m and n are integer values, positive integers, then they refer to polynomial expressions. Otherwise, they can be any function, but you can easily integrate this function between 0 to 1. So, integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 dx. If m comma n are certain values, whenever this integral is finite value. Whenever we use exists, it refers to a finite number. It refers to a finite number. That means, why I am using frequently the integral exists, beta function may not exist for all real values m and for all real values n. Whenever for certain values of m and n, if this integral gives finite value, then beta of m comma n is denoted by this integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 dx. Let us take one sample example. Suppose let us calculate for example beta of 2 comma 3. Now m value 2, n value 3. So this becomes integral 0 to 1. Replace m by 2, it becomes 1. Replace n by 3, this is 1 minus x whole square dx. So therefore this is integral 0 to 1 x into, this is x square minus 2x plus 1 dx. Now this is integral 0 to 1 x cube minus 2x square plus x dx. Now let us integrate this. Therefore beta of 2 comma 3 equal to integral x cube is x power 4 by 4. Integral 2x square 2x cube by 3 plus integral x is x square by 2. Limits are from 0 to 1. So this is 1 by 4 minus 2 by 3 plus 1 by 2. So here the LCM is 12. This is 3, 4, 8, 6. So therefore this value is 1 by 12. Beta of 2 comma 3 is 1 by 12. Now it's a simple calculation for small values of m and n. If I take complicated values for m comma n, how to handle this? I give you one simple relation between beta and gamma functions so that you can easily handle beta function even for complicated values of m and n also. Okay. So at first write this definition. Let m comma n be two real numbers. Let m comma n be two real numbers. Then beta function for m comma n. Then beta function for m comma n is denoted and defined as. Then beta function for m comma n is denoted and defined as beta of m comma n equal to, beta function for m comma n is denoted and defined as beta of m comma n equal to this integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 dx, provided the integral exists. provided the integral exists. So you write down this calculation. Example. Now we give relation between beta and gamma functions. The relation is this: beta of m comma n equal to gamma of m into gamma of n divided by gamma of m plus n. This is the relation between beta and gamma functions. Now even when you give large values of m and n, you can handle easily this integral by using gamma functions. So previously we calculated beta of 2 comma 3. So this is gamma of 2 into gamma of 3 divided by gamma of 2 plus 3. Here gamma of 2 is 1 factorial because gamma of n is n minus 1 factorial. Gamma of 3 is 2 factorial divided by gamma of 5. This is 4 factorial. So 2 factorial is 2, 4 factorial is 24. This value is 1 by 12. Even we proved it earlier. Gamma of beta of 2 comma 3 is 1 by 12. So this is a strong relation between beta and gamma functions. Its advantage is you can easily get beta of m comma n even for large values of m and n also. And another useful point is beta of m comma n equal to beta of n comma m. So exchange m and n, still you will get the same, and this is called symmetric property. This is called symmetric property. And one more information about this beta functions is this. Suppose I have a different integral, this integral 0 to pi by 2 sine power nx into cos power mx dx. 0 to pi by 2 sine power nx into cos power mx dx. N values, m values can be same, can be different. So this integral is half into beta of n plus 1 divided by 2 comma m plus 1 by 2. So therefore using beta functions you can easily integrate sine power nx into cos power mx between 0 to pi by 2. So all these are very useful points. Note down these points. Next definition, bounded integral. Suppose we have an integral a to b f of x dx. Whenever this value is a finite value, don't think that this value is always finite. If you take some different limits, the value may not converge to finite limit. Converge means it approaches. So if this integral is a finite value, then we say that this integral is called bounded integral. Basically bounded means a limited area, finite value. So whenever we say that suppose this is unbounded, this is bounded. Bounded means we have some specific region, it has some boundaries. So whenever an integral a to b f of x dx gives some finite value, then such integrals are called bounded integrals. Say for example, if I have an integral like this, integral minus infinity to plus infinity 1 by 1 plus x square dx. That means we are integrating this function on entire x-axis. These are limits of x-axis. Now let us see, this value is actually tan inverse x. Limits are from minus infinity to plus infinity. Tan inverse infinity is pi by 2. Minus tan inverse of minus infinity is minus pi by 2. So this value is pi. Therefore, this integral is giving finite value. So this is an example of a bounded integral. Okay, or this. An integral a to b, integral a to b f of x dx. An integral a to b f of x dx is said to be bounded if it gives a finite value or if it converges to a finite value. Converges means approaches. So an integral a to b f of x dx is said to be bounded if it converges to a finite value. If it converges to a finite value. Note this example. Integral minus infinity to plus infinity 1 by 1 plus x squared dx. So when you evaluate this, we get 5. Now let us start classroom workbook. So we start a classroom workbook from question number 57. 57. If A is a positive constant, then the value of the integral a square into integral 0 to infinity x into e power minus ax dx is what? We need to find this integral a square into integral 0 to infinity x into e power minus ax dx. You can see the limits are from 0 to infinity and exponential function is there with a minus before x. Therefore, definitely it leads to gamma function. I will write gamma function. This is gamma of n is integral 0 to infinity e power minus x into x power n minus 1 dx. Now, inside this integral, in the exponential function, after minus n, we have the power of x is 1. And here it must be single variable x. But here before x, we have a constant a. Therefore, in order to convert this into gamma function, we take ax equal to some new variable p. So let ax equal to p. This implies a into dx equal to dp. This implies dx equal to dp divided by a. But these are limits of x. So x is converted to new variable p. So what is upper limit of p? Here upper limit of p is a times infinity, because the upper limit of x is infinity. A into infinity. A is a positive number, so it is plus infinity. Lower limit of p. So replace x by the lower limit 0. A into 0, 0. So lower limit is 0, upper limit is infinity. Therefore, this becomes a square into limits are not changing, integral 0 to infinity x. When ax equal to p, what is x value? X is nothing but p divided by a. So in place of x, we can write p by a into e power minus p. This dx is replaced by dp divided by a. So this a square into a square gets cancelled. Therefore, this integral is integral 0 to infinity e power minus p into this p, we can write it as p power 2 minus 1 into dp. Now this is a gamma function in terms of variable p, but the value of n is 2. So this is gamma of 2. Gamma of 2 is 1 factorial. So this is 1. Therefore, the value of this integral is 1. Simple point is, when you are handling functions, when you are handling integrals, look at the limits. If they are ranging from 0 to infinity, see, look at the function. If the function contains exponential function, so definitely it will be in the form gamma function. So try to convert that in the form gamma function and apply suitable formula, you get the values. Okay. So therefore, in this case, its value is 1. Work out this. Now let us discuss question number 58. The integral 0 to infinity x square into e power minus x square dx is the answer up to 2 decimal places. Answer up to 2 decimal places. Now here exponential function is there. Limits are ranging from 0 to infinity. So definitely you can manage this with gamma function. But here minus x should be there, but instead of x we have x square. So you can take p equal to x square. So dp equal to 2x dx. Now in that case, what is the dx value? Dp by 2x. But the same limits will work even for p also. Upper limit of p is infinity square, infinity. Lower limit of p equal to 0 square, it is 0. Same limits are working even for p also, 0 to infinity. Now let us see where here dp equal to 2x dx. That means dx equal to dp divided by 2x. So this is dp divided by, when x square equal to p, x equal to square root of p. Therefore dp by 2 times square root of p. Now let us apply this in this integral. So we get integral 0 to infinity. Here x square is p. So this is p. E power minus x square means e power minus p. Now this dx is dp by this. So dp divided by 2 times square root of p, like this. Therefore this is 1 by 2 into integral 0 to infinity e power minus p into p by square root of p. So this is p power 1 by 2 dp. So this is 1 by 2 times integral 0 to infinity e power minus p into, I must convert this number into n minus 1 form. So this 1 by 2 can be written as 3 by 2 minus 1. Now when you observe this, it is integral 0 to infinity e power minus p into p power n minus 1 dp. It is a gamma function, but the value of n is 3 by 2. So this is half into gamma of 3 by 2. But we know that gamma of 3 by 2 is root pi divided by 2. So therefore this is root pi divided by 4. Simplify this value. Here pi is nothing but 3.14. So simplify this and take the value up to 2 decimal places. 0 to 1 dt by square root of minus log t to the base e is what? So options are given. Let us see how to handle this. It is quite interesting question. Limits are ranging from 0 to 1. So when generally limits are ranging from 0 to 1, we expect beta function. But in the beta function, you should have powers of x only. Here variable is t, so you must have powers of t. But here log functions are there. So inside our square root, we have a minus symbol. So when you have square minus inside minus, minus inside square root, you get complex roots. But we are not handling complex integrals. Okay. So what I will do is, let p equal to square minus log t to the base e. So here differentiate this. So t is converted to new variable p. Minus log t to the base e. Minus should not be there inside square root. So take this minus log t to the base e into new variable p. Differentiate this. What is the derivative of log t? 1 by t. Or if I take minus 1 by t, I don't think so I get any advantage. Let us think in the different way. When p equal to minus log t to the base p, so in this case minus p equal to log t to the base e. This implies the value of t is e power minus p. Therefore this implies dt equal to minus e power minus p dp. Now we got exponential function. So slowly we were reducing to gamma function. So dt is minus e power minus p dp. But here p is converted, t is converted to p. So let us find the limits. So here what is p? P is minus log t to the base e. Upper limit of p equal to minus log, what is upper limit of t? 1. Log 1 is 0. Now let us find lower limit. Lower limit of p equal to minus log, here log minus log t to the base e, but lower limit of t is 0. Minus log 0 to the base e. What is log 0? Log 1 is 0, but log 0 is not 1. Here log 0 is minus infinity. I will tell you, e power minus infinity is 1 by e power infinity. This is 1 by infinity. We know that 1 by infinity is 0. So the result is e power minus infinity is 0. Apply log on both sides with base e. Then you will get log 0 to the base e is minus infinity. Already here minus is there. So this minus and this minus becomes plus infinity. See the magic? Limits are converted to 0 and infinity. Therefore, this integral will be lower limit is infinity, upper limit is 0. This dt will be equal to this minus of this. So minus e power minus p dp divided by this is square root of p. Now because of this minus I can exchange lower and upper limits. So integral 0 to infinity e power minus p into 1 by root p, we can write it as p power minus 1 by 2 into dp. So this is integral 0 to infinity e power minus p into this minus 1 by 2, we can write it as 1 by 2 minus 1 dp. Now this is a gamma function, but the value of n is 1 by 2. So gamma of 1 by 2, which is nothing but square root of pi. Therefore, finally it is reduced to gamma function and gamma of 1 by 2. So it is square root of pi. Note this.